Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 20 and today again we are going to solve a problem based on heap data structure and the level of this question is going to be hard. The name of this question is find median from data stream. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on Leetcode. So here we are on Leetcode. Let's read our question. So the question says the median is the middle value in an ordered integer list. Okay. If the size of the list is even, then there is no middle value and the median is the mean of the two middle values. So this is nothing but a normal definition of median. Okay. And here are some sample test cases or some examples. So for this particular example, we can see that the size of this array is 3, which is an odd number. So the middle element exists. So the middle element is 3 and it is our median also. And for this particular example, the size of array is 2, which is an even number. So in case of even, the middle element does not exist. So in that particular case, the median is nothing but the average or mean of the two middle values. Therefore, the median is 2 plus 3 divided by 2, which is equal to 2.5. Okay. And here the question says that we have to implement the median finder class where we have one constructor, correct? And we have to implement these two functions. The first function is void add num, right? And what it does, it adds the integer num from the data stream to our data structure. And then we have another function named as double find median. It returns the median of all the elements so far. Answer within 10 to the power minus 5 of the actual answer will be accepted. Okay. And here we have one sample test case. Okay. So let's analyze this problem by taking some examples and then we will think of how we can solve this problem. So let's take this example number 1. Okay. So here you can see that the size, here you can clearly see that the size is equal to 6, right? And this is our array, or these are the numbers for which we have to find out the median. Okay. So to find the median, what we have to do, firstly we have to sort our data, right? So after sorting, our data will look something like this, right? And here you can see that the size is equal to 6, which is an even number. So the middle element does not exist. So what we have to do, we have to find the average of the two middle elements, right? And the two middle elements are nothing but 5 and 7. So in this case, the median will be equal to 5 plus 7 divided by 2, right? Similarly, if we take this particular example, example number 2, so here you can clearly see that the size is equal to 5, which is an odd number. But before finding the median, what we have to do, we have to sort our array, right? We have to sort our input. So this was our input. After sorting, it will look something like this, correct? And here the size is equal to 5, which is an odd number. So we know that the middle element exists. So this 5 is our middle element and this is our answer, right? This is our median, correct? So I hope it is clear to you. But the question is not that easy, right? The question says that you have given an input stream, right? We does not have given any array into our input. Okay. So let's say that we have a function named as add num, right? What it does, it gives us a number. Let's say the number is 5 and we need to add it into our data structure, right? And the data structure can be anything. It can be array, it can be vector or anything else. Okay. Okay. So firstly, the question says that you have to add 5 into our data structure. So we have added 5 into our data structure, right? Then the question says add 4 into your data structure. So we have added 4 again into our data structure. And now the question, at any point, the question can say to find out the median. Okay. So after these two steps, right? After doing these two steps, let's say the question says to find out the median. What will be our median, right? So in order to find out the median, firstly, we have to sort our array, right? Firstly, we have to sort it. So here we can see that the input is already sorted into ascending order, right? And here, if you clearly see, then the size is equal to 2, right? Because we only have 2 elements into our data structure, which is an even number. So the middle element will not exist in this particular example, right? So the median will be 4 plus 5 divided by 2, which is nothing but 9 by 2, which is nothing but 4.5. Okay. After this step, let's say the question again says to add one element 8 into our data structure. So we have added it. And after doing this, if the question says to find out the median, so what we have to do, firstly, we need to make sure that the data is stored into ascending order, right? Here you can clearly see that the data is already stored into ascending order. And now what we have to do, we just need to find out the middle element. Why? because here the size is equal to 3 and 3 is an odd number. So we just need to find out the middle element. Middle element is nothing but 5. So this 5 will be our median. So let's say the question says that we need to add 8 into our data structure. So after adding 8 into our data structure will look something like this, right? And next, if the question says to find out the median, then how we will find out the median? For finding out the median, we need to make sure that our data into our array are sorted into ascending order. Here you can clearly see that the data is already sorted into ascending order, and then we need to find out the median. So before finding out the median, we need to find out what is the size of our array. So the size is equal to 4, which is even. So the middle element does not exist. So what we need to do, we need to find out the average of the two middle values. So the two middle values are nothing but 4 and 5. Therefore, the median for this case will be 4 plus 5 divided by 2. Correct? Similarly, after doing this step, let's say the question says to add 12 into your data structure. So after adding 12 into our data structure will look something like this. And again, after this step, if the question says to find out the median, then we have to find out the median, right? But before finding out the median, it is very important to make sure that the data is stored into ascending order. Correct? Here you can say that the data is already stored into ascending order, right? And here the size is equal to 5, which is an odd number. So we know that the middle element exists, and here the middle element is nothing but 5. So this 5 will be our median. So I hope the question is clear to you. You have understood how we need to find out the median if the number of input is an even number or if the number of input is an odd number, right? So question basically says that we are getting input from our input stream, right? And at any step, the question can ask us to find out the median. Okay, so I hope it is clear to you. So now let's try to discuss the most brute force approach which can come to our brain when we see this particular solution. Okay, so let's say that initially we have a vector or we have an array which is initially empty. Okay, which is initially empty, and as we will get input from our input stream, we will add it into our vector or into our array. And if the question says to find out the median, we will probably find out our median. Okay, so let's say firstly the question says to add 5 into our data structure. So we will add 5 into our array, or you can call it as vector as well, right? So after adding, my data structure will look something like this. Now, in order to find out the median, I need to make sure that this data is sorted, right? So my second step would be to sort my array, right? The second step would be to sort my array. After sorting my array, if the question says to find out the median, I can probably find out my median. Okay. So here you can see that into my array, I have only one element, or you can say that the size of my array is equal to 1, which is odd, right? If it is odd, then the middle element definitely exists. And you can clearly see that the middle element is nothing but 5. So 5 is my median as well. Okay. Now, after doing this step, let's say the question says again to add 4 into your data structure. So what we'll do, we will add 4, right? This is not 5. This is 4. We will add 4 into our array. And after adding 4 into our array will look something like this. Okay. Now, in order to find out the median, it is important to sort our data structure, right? After sorting, our array would look something like this. And if again the question says to find out the median, we can probably find out the median, right? Here the size is equal to 2, which is an even number. So the middle element does not exist. So the median will be the average of the two middle values. And the two middle values are 4 and 5. So we'll add them and we will divide them by 2. So our answer will be 4.5, and this will be our median for this particular example. Now let's say the question says to add 8 into your data structure. So our first step is very simple. We will add 8 into our data structure, and after adding it into our data structure would look something like this. And in order to find out the median, we need to make sure that our data structure or our array or our vector is sorted. So we will sort them, and after sorting, we can probably find out our median. Correct? So here you can see that we have 3 number of elements, and 3 is an odd number. So you can clearly see that the middle element exists, which is nothing but 5. So this is our answer. After performing this step, let's say the question again says to add 2 into your data structure. Then we will add 2 into our data structure. Correct? And in order to find out the median, we need to make sure that our data structure is sorted, right? So we need to sort our data structure, and after sorting, our data structure would look something like this. Again, if the question says to find out the median, we can definitely find out the median. Okay. So here you can see that the size is equal to 4, which is an odd number. So we does not have any middle element, right? So the median will be the average or the mean of the two middle values, right? Or you can clearly see here the two middle values are 4 and 5. So the median will be 4 plus 5 divided by 2. Correct? Now let's say the question says to add 7 into your data structure. So what we'll do, we will simply add 7 into our data structure. Correct? And in order to find out the median, it is very important to make sure that our data structure is sorted. So then we will perform the sorting operation, and after sorting operation we can probably find out our median. Okay, here the size is equal to 5, which is an odd number, so we can definitely find out the element which is present at the middle. So this 5 is our middle element, so the median for this particular case will also be equal to 5. Okay, now let's say the question says to add 12 into your data structure. So we will add 12 into our data structure, and in order to find out the median, we need to make sure that our data structure is sorted into ascending order. So we'll perform the sorting, and after performing the sorting we can find out our median. Correct? Okay, so here you can see that the size is equal to 6, right? The size is equal to 6, which is an even number. So the middle element does not exist. If the middle element does not exist, then median is nothing but the average or mean of the two middle values, correct? So here the two middle values are nothing but 5 and 7. So our median will be 5 plus 7 divided by 2, correct? So I hope this is clear to you, right? So what we were doing in this particular dry run or in this particular approach, correct? What we were doing, we were having a data structure, right? We were having a vector, right? You can use a vector. If you are using an array, then you have to make sure that you have to also declare the size of the array as well, right? Therefore I'm using vector. You can use array as well, but if you are using an array, then you have to make sure that you are defining the size of the array as well. Okay, so let's say that we are using a vector. So what we are doing, whenever the question says to add any number into our data structure, we are just simply adding it into our data structure, correct? Now after adding, if the question says to find out the median, then only we will sort our data structure, and then we will probably give our median. Okay, so what will be the time complexity? See, if we talk about the time complexity for adding any number into a data structure, then it is nothing but O of 1, right? The time complexity for adding any number into our vector is nothing but O of 1, correct? But if the question is to find out the median, so for finding out the median, firstly we need to sort our data structure, correct? We need to sort our data structure, and in sorting, the time complexity will be O of n log n. And after performing the sorting, we can probably return our median. Okay, so if we are following this particular approach, then the time complexity for adding a number into a vector will be nothing but O of 1 or constant, and the time complexity for finding the median will be equal to O of n log n. Okay, but this is not the most optimal approach for this particular problem. So now let's try to discuss the most optimal approach for this particular problem. Let's say this is our input, and for this input we need to find out the median. Okay, so before finding out the median, we need to make sure that our data is sorted. Okay, so what we'll do, we'll sort our vector or we'll sort our array, and after sorting we can probably find out our median. Okay, so this is our data after sorting. Okay, now let's say we need to find out the median. So before finding out the median, we need to see that what is the size. You can see that the size is equal to 6, which is an even number, correct? It is an even number. So the median will be nothing but the mean of the two middle values, right? And these are 5 and 7 are the two middle values. So our median will be 5 plus 7 divided by 2, which will be equal to 6. Okay, which will be equal to 6. So this is the answer for this particular example. But if we solve our input, again and again, then the time complexity will be equal to n log n, right? And we are trying to reduce this time complexity, right? So we need to think about something which takes some lesser time complexity than n log n. Okay, and if you know that whenever we are working with the sorting algorithm, right, whenever we are working with the sorting algorithm, we can probably use of heap, right? We can probably use of heap data structure, because we know that if we are storing elements into our heap data structure, then it will be automatically sorted either into ascending order or either into descending order. Okay, so let's say that we are using a maximum heap. Okay, let's say that we are using a maximum heap, right? So instead of again and again sorting our data, we can store elements which we are getting from our input stream. We can directly store them into our maximum heap. Okay, and after storing them into our maximum heap, we can find out the median element, because if we are storing them into our maximum heap, then we know that our maximum heap is already storing them into sorted order. Okay, so let's say for this particular input, we have stored all our input into our maximum heap, and then if we try to find out the median, right? So what will be the median? Here you can see that the size is equal to 6, which is an even number. So we need to find out the median. So the median will be sum of the median will be mean or average of the two middle values. But there is a problem with heap data structure. In heap data structure, we cannot find out elements from their index. Okay, there is nothing like index in max heap or even in minimum heap. Okay, so in order to solve it, what we can do, that we can store all the elements from maximum heap into a array or into a vector, right? So after storing them into a vector or into a array, it will look something like this, correct? Will look something like this, and then we can probably find out the two middle elements. They are nothing but 5 and 7. But if we are following this particular approach, then what will be the time complexity? See, firstly, we are putting all the elements from our array or from our input stream into our maximum heap, and whenever we do a push operation into max heap, then the time complexity is equal to log n, correct? And whenever we are doing a pop operation from the max heap, then again the time complexity is equal to log n, right? So if you will follow this particular approach, then the time complexity will be nothing but n log n, correct? Because in total there are n number of elements which you need to store into your maximum heap, and for every push operation and for every pop operation, the time complexity will be log of n. Okay, so this is not a good approach to solve this problem, right? It does not solve our problem. We need to find out a solution which takes lesser time complexity than n log n. So we cannot use this particular approach. So we know that we cannot directly use a minimum heap or a maximum heap to solve this problem, because it will not reduce our time complexity. But again, in this problem, we have to work with sorting, right? We have to work with sorting. We have to again sort our data again and again whenever we are getting a data from our input stream. Okay, so this hint is enough for us to understand that this problem will definitely get solved by using heap, right? Either by maximum heap or by minimum heap, right? So now let's try to understand how we can utilize heap data structure to solve this particular problem. Let's say that the number of elements into our data structure is equal to 6, which is an even number. So just think about it. If it is an even number, and if we need to find out the median, then which elements do we need? We just need the two middle elements, right? Which is nothing but 5 and 6. We just need these two elements, right? I just need 5 and I just need 6 in order to calculate the median. Okay, I know that I cannot use a single heap to solve this problem, but instead of using a single heap, can I use two different heaps? Let's try to see this. Okay, let's say that I am using two different heaps, right? This is my heap number 1, right? Let me call it as left, correct? The spelling of left is wrong, so it will be left. And let's say that this is my another heap, right? Let me call it as right, ri. Let me call it as right. Okay, so if I have two different heaps, right? One is the left heap and one is the right heap, then can I find out the median? The answer is yes, I can definitely find out the median, because from the left I will get this 5 and from the right I'll get this 6, right? And then I can probably calculate the median. But again, the question is, this left heap should be a minimum heap or a maximum heap? Again, this right heap, it should be a minimum heap or a maximum heap. So let's analyze. See, in the left heap, in the left side, you can clearly see that the data is sorted into ascending order, correct? The data is sorted into ascending order. And here in this particular box, right? In this particular box, you can see that this 5 is nothing but the maximum element, right? It is nothing but the maximum element. So for the left portion, I can use max heap, right? Why I am using a max heap? Because we know that at the top of a max heap, we get the maximum element, right? And in order to find out our median from this particular box, we need to get the maximum element, correct? Similarly, if we see this right box, if I am seeing this right box, you can clearly see that we need this 6. We need this 6. And this 6 is nothing but the minimum element present into this box, right? So what I can do here, I can use a min heap, correct? Why I am using a min heap? Because I know at the top of my minimum heap, I will have the minimum element, right? I will have the minimum element. And in order to find out the median for this particular case, what I can do, from this maximum heap, I can get the element which is present at the top. Similarly, from this minimum heap, I can get the element which is present at the top, correct? And then I can just add them and divide by them by 2 to get my answer. Okay, but But let's say that instead of having size equal to 6, which is an even number, let's say the size is an odd number. Then how this algorithm will work? So in this particular example, you can clearly see that the size is equal to 5, right? And here as well, the concept or the idea which we are going to use is same. We are going to divide our data into two different heaps, right? Into two different heaps. But again, here the question is, the size is equal to 5, right? So I cannot divide them into two equal parts. I cannot divide them into two equal parts. So what I'll do, I will say that in one particular heap, I will have one extra element as compared to the another heap. Okay, let me explain it to you. Let's say that this is my left heap, right? This is my left heap and this is my right heap, correct? So now instead of having equal number of elements in left and in right heap, I have decided that in the left heap, I can have one extra element as compared to the right heap. If the number of elements is an odd number, then I cannot store elements equally in left and right heap, okay? I need to make sure that in one particular heap, I'll have one extra element, right? So here you can see that in left, I have 3 elements and in the right, I have 2 elements, correct? And now I can simply say that if the number of elements are odd, then what will be my median? You can clearly see that the median is this 5 because it is the middle element. And if I'm storing it into my left heap, if I am storing it into my left heap, which is a maximum heap, then this is nothing but left dot top. Okay, left dot top. So if the size is odd, then I can directly return the top element from my left heap. Okay, so now let's take one sample test case to dry run this particular approach so that this approach will get fitted into your mind and you will understand it in more depth. So as we had discussed, in order to solve this problem, we will use two different heaps, right? The first one will be my left heap, which will be nothing but a maximum heap. The second one will be a right heap, which will be nothing but a minimum heap, okay? And we will get input one by one from our input stream, okay? So let's say that initially I got this 5 from my input stream. Now I need to think of, should I store this 5 into my left heap or should I store this 5 into my right heap, okay? Now, if I ask you, when you received this 5, then how many elements do you got, right? How many inputs do you have? So you will say that I have just one input, which is equal to 5, correct? And this one is nothing but an odd number, right? And I told you, whenever we are having odd number of inputs, then we will have one more extra element into my left heap as compared to my right heap, correct? So you can see that into my right heap, I have 0 number of elements. Into my left heap, I have 0 number of elements. And if the number of input is odd, then I will have one extra element into my left, right? So I should have one element here into my left. So therefore, what I'll do, I'll store this 5 into my left, right? I will store this 5 into my left heap. Now, at this particular moment, if the question says to find out the median, so we can clearly see that the number of inputs is 1, which is odd, right? The number of inputs are odd. And if the number of inputs are odd, we know that our median is stored at the top of our left heap, right? At the top of our left heap, we have this 5. So this 5 is our median up to this portion, right? Up to this point, okay? Let's say that after getting this 5, I got one more element 4 from my input stream, right? We got one more element 4 from our input stream. Now we need to again think of, should I store this 4 into my left heap or into my right heap? So how I will decide that? It is very easy. What I'll do, I will take the topmost element present into my left heap, right? So in my left heap, the topmost element is 5. So I will take it out, okay? Now I will compare, is this 4 is greater than 5 or not? You will say that, no, this 4 is lesser than 5, okay? So if this 4 is lesser than 5, if it is lesser than 5, it means that I should store it into my left heap, right? I should store it into my left heap because at the top of my left heap, I will have the maximum element, correct? So I hope it is clear to you. So I will store this 4 into my left heap and we know that our left heap is a maximum heap. So at the top of our left heap, we should have the maximum element, which is 5. Okay, I hope it is clear up to this point. Now again, if the question says to find out the median, then how we will calculate our median? Firstly, we need to see that how many number of inputs do we have. So we have this 5 we have this 4. So the number of inputs are equal to 2, which is even, right? Which is even. Now, I told you if the number of inputs are even, then we should divide our input into two equal parts, right? We should store our inputs equally into left and right heap, correct? But here you can see that in my left heap, I have 2 elements, but in my right heap, I have 0 elements, right? And the number of inputs are even. So what I'll do, I will store the topmost element from my maximum heap into my minimum heap, right? What I'll do, I'll remove this 5 from my left heap and I will store it into my right heap, right? So I will store 5 here into my right heap, correct? Now again, if the question says to find out the median, you can clearly see that the number of inputs are even, okay? If the number of inputs are even, then our median is nothing but we take the top element from the left, which is 4. We will take the top element from the right, which is 5. We will add them, we will divide them by 2, and this will be our median, okay? So I hope it is clear to you, right? Now let's say that we received this 2 from our input stream, okay? Now we have to think of, should I store this 2 into my left heap or into my right heap, okay? So what I'll do, I will compare this 2 with the maximum element or with the topmost element present into my left heap, right? So the topmost element present into my left heap is nothing but 4. I will compare it. Is this 2 is lesser than 4? You can clearly see that yes, this 2 is lesser than 4. If this 2 is lesser than 4, it means that I can store this 2 into my left heap, okay? So what I will do, I will store it into my left heap. So firstly, I'll have 4, then I will have 2, correct? Why this particular order? Because we know that our left heap is nothing but a maximum heap, and in the maximum heap at the top, we have the maximum element, okay? Now at this particular moment, if the question says to find out the median, firstly, we need to think of how many number of inputs do we have. So we have this 5, 4, and 2. So the number of inputs are equal to 3, which is odd. And I told you if the number of inputs are odd, then our median will be stored at the top of our left heap, right? So at the top of our left heap, we have 4, and this is our answer. If you are confused, let me show you. Let's say that we have this 5, 4, and 2 from our input, okay? And we need to calculate the median, okay? So how we calculate median? Generally, we sort our data, okay? So after sorting, our data would look something like this, okay? And here you can clearly see that the number of inputs are equal to 3, which is an odd number. So the middle element exists, and you can clearly see that the middle element is nothing but 4. So 4 will be our median. And from this left heap, we are also getting 4, okay? So it means that this 4 is indeed our median, okay? So I hope now you have understood this, right? Now let's say the next input is 6, right? The next input is 6. What I'll do, I'll again compare this 6 with the topmost element of my left heap, right? So at the top of my left heap, I have 4, and the current element is 6, right? So I will see, is this 6 is lesser than 4 or not? So you can clearly see that this 6 is not lesser than 4. This 6 is greater than 4, okay? Now, if the current element is greater than the top element of my left heap, I'll store this current element into my right, okay? See, because we know that into my left heap at the top, I'll have the maximum element, right? And now when I'm receiving someone who is greater than my maximum element, then I should store it into my right heap, right? I should store it into my right heap. So what I'll do, I'll store into my right heap, okay? But the right heap is a minimum heap, okay? So the data will be stored into ascending order. Now at this particular moment, if the question says to find out the median, how we will calculate the median? Firstly, we will say how many number of inputs do we have? So we have this 5, we have 4, we have 2, we have 6, okay? And the number of inputs are 4, which is even. Now to calculate the median, what we'll do, we'll sort it. So after sorting, it would look something like this. And if the question is to find out the median will be average of this 4 and 5, right? So we will add this 4 and 5, and then we will divide it by 2. So our median will be 4.5, okay? This will be our answer. So let's say that we are getting this 4.5 or not from our approach, okay? So the number of inputs are 4, which is even number. And I told you, whenever the number of inputs are even, what we'll do, we will take the topmost element from the left heap, which is nothing but 4. We will take the topmost element from the right heap, which is nothing but 5. We will add them and we will divide them by 2, okay? So you can see that we clearly that we are getting 4.5. So this is the correct median for this particular input. Now let's say I received 12 from my input stream. Okay, so again I will think of, should I store this 12 into my left heap or into my right heap? So I'll take the topmost element from my left heap, which is 4, and the current element, which is nothing but 12. I will again see that is this 12 is lesser than 4 or not. You can clearly see no, this 12 is greater than 4. Now whenever the current element is greater than the topmost element of my left heap, I will store the current element into my right heap. Okay, so I will store it here into my right heap, but my right heap is a minimum heap, so at the top I'll have the minimum element. So the sequence will be this 5, 6 and 12 into my right heap. Okay, now if the question says to find out the median, so how we will do that? Firstly, we need to calculate how many number of inputs do we have. So we have 1, 2, 3, 4 and 5, right? We have 5 number of inputs, and this 5 is odd. But I told you that whenever we are having odd number of inputs, then in the left I will have one extra element as compared to right. Okay, but here into left I have 2 elements, and here into right I have 3 elements. So right now the situation is opposite. In my right I have one extra element. Okay, so what I'll do, I will remove one element from my right heap and I will store it into my left heap. Okay, so what I'll do, I'll remove the topmost element, which is 5, and I will add it into my left heap, right? I will add it into my left heap. So now at the top of my left heap I have 5, and at the top of my right heap I have 6. Correct, and the number of inputs are 5, which is odd. So if the number of inputs are odd, then our median will be present at the top of our left heap. Okay, so at the top we have 5, and this 5 is indeed our correct answer, right? If you have some doubts, let me just show it to you. So we have 5, 4, 2, 6 and 12 into our input. Okay, now in order to find out the median, what we'll do, firstly we'll sort it. So after sorting, our input would look something like this. Okay, and the indexes are this. Okay, so what are the number of elements? So the number of elements are nothing but 5, which is odd. So the middle element exists, which is nothing but 5, and this is our median. Correct, and from this approach as well we are getting 5 as our median. Okay, so I hope it is clear to you. Now let's say we got 8 from our input stream. Again we will think of, should I store it into my left heap or into my right heap? So what we'll do, we'll compare it with the top of my left heap. So at the top of my left heap I have 8, I have 5, and I'll store it with the current element, which is 8. I'll see that is this 5 is greater than 8 or not. So you will clearly see that no, this 8 is greater than 5, right? So now what I will do, whenever the current element is greater than the maximum or the top of the left heap, then I will store my current element into my right heap. Okay, so I will store 8 here. I'll store 8 here, but the right heap is a minimum heap, so this will not be the sequence. The sequence will be 6, 8 and 12. Now at this particular moment, if the question says to calculate the median, then how many number of inputs do we have? We have 6 number of inputs. Okay, then how we'll calculate the median? We will take the topmost element from the left heap, which is nothing but 5. We will take the topmost element from the right heap, which is nothing but 6. We will add them and then we will divide it by 2, so that we will get our median. Okay, I hope it is also clear to you, right? Now after this, let's say that our next input is 7, right? Our next input is 7. So we need to think of, should I store it into my left heap or should I store it into my right heap? Okay, so what I'll do, I'll take the topmost element from my left heap, which is nothing but 5, and I will compare it with 7. I will see that is this 7 is lesser than 5 or not. You will see that no, it is not, right? You can clearly see that the 7 is greater than 5. Now if the current element is greater than the maximum of my left heap, I'll store the current element into my right heap, right? I will store it into my right heap. But we know that our right heap is what? Our right heap is a minimum heap, right? Is a minimum heap. So our data will stored into ascending order. So firstly I'll have 6, then I will have 7, right? Now at this particular moment, if the question says to find out the median, but before finding out the median, we also need to think of one thing. Okay, see, at the left we have 3 number of elements, and at the right we have 4 number of elements. Correct, and what are the number of inputs do we have? The number of inputs are 1, 2, 3, 4, 5, 6 and 7. So the number of inputs are odd. Correct, and I told you if the number of inputs are odd, then in the left I should have one more element as compared to right. But here the situation is opposite. So what we'll do, we will take the topmost element from the right, I will pop it and I will add it into my left heap, right? I will add it into my left heap. And after doing this, if the question says to find out the median, you can clearly see that the number of inputs are odd, right? The number of inputs are odd, and if the number of inputs are odd, then our median is present at the top of my left heap. So at the top of my left heap I have 6, and this 6 is my median. Okay, so I hope this particular dry run is clear to you. If it is not, then make sure you do some dry runs by taking some different examples, and if you will do 2 to 3 dry runs, then this particular approach will get very clear to you. Okay, so now let's think of how we are going to code this approach. So as I always say, coding is the most easiest part if you have understood the approach. Okay, so in order to code this, what do we need? Firstly, we need a left heap, right? And we need a right heap. Okay, so this left heap is nothing but a maximum heap, and the right heap is nothing but a minimum heap. Okay, now we have two functions, right? The very first one is void add num. Okay, and here we will get a number, right? We will get an integer number, and we need to store this integer number, right? So we are getting this number from our input stream. Okay, so should I store it into my left heap or should I store it into my right heap? What should I do? So I can write a condition here that if my left heap is empty, right? If the left heap is empty, or this number is lesser than the topmost element from my left heap. Okay, if this is the case, then store this particular number into my left heap, right? So I will store it into my left heap. So here I will write left push number. Okay, I will push it into my left heap. If this is not the case, then what I'll do, I will push this particular number into my right heap, right? I will push it into my right heap. This condition states that if I have more number of elements into my left heap as compared to number of elements into my right heap plus 1, if this is the scenario, then I need to balance out the number of elements. Okay, so what I'll do, I will push element from my left heap into my right heap. Okay, so here I will write right dot push left dot top. Okay, and after doing this, what I will do, I will pop out element from my left heap, right? So here I will write left dot pop. Okay, so now the number of elements will get balanced. Okay, else if let's say that we have more number of elements in right side, the right dot size is greater than or even equal to left dot size plus 1, right? If we have more number of elements in the right heap as compared to the number of elements in left heap plus 1, then what do we need? We need to pop out element from our right heap. Okay, so before popping out, I need to push that element into my left heap. So how I'll do that? Here I will write left dot push right dot top. Okay, and then I will perform a pop operation on right. So here I will write right dot pop. Okay, and after writing these two conditions, the number of elements in left and right heaps will be balanced. Okay, I hope it is clear to you. Now in the question, we have one more function, right? We have one more function which is nothing but double find median. Okay, double find median. Now this particular function is going to be very easy for us. Okay, so see, firstly we'll write a condition that if the left dot size is exactly equal to right dot size, if this is the case, it means that we have even number of elements, right? We have even number of elements, and if we have the even number of elements, then I can directly return the average of the top elements from my left and right heap. So here I can just directly return left dot top, okay, plus right dot top, and then just divide it by 2, correct? But here you can clearly see the return type is double, so we need to convert it into double as well. Okay, and now if this is not the case in the else block, right? If this is not the case, it means that we have odd number of elements. Now if the number of elements are odd, then we know that our median will be stored at the top of our left heap, correct? So I also need to typecast it into double because the return type for this function is double. Okay, so I hope the code is clear to you, the approach is also clear to you. So now let's analyze the time complexity for this particular solution. Okay, so in the void add num function, what we are doing, we are just storing our element either into the left heap or either into the right heap, and then we are doing some adjustments. Okay, so at first the time complexity will be equal to log n. Okay, where this n is nothing but the size of our heap. Okay, the n can be the size of my left heap or it can be size of my right heap. Okay, I'm just taking it in a general way. Okay, and if we talk about the space complexity, then what we are using two different heap. Okay, but in those two different heaps, what we are storing, we are storing the number of elements into two equal parts. Okay, so you can say that the space complexity will be equal to O of n by 2 plus O of n by 2, or it is approximately equal to O of n. Okay, so these are the time and space complexity for this particular solution. I hope it is clear to you. Now let's go to Leetcode and finally code it up. So now we are here on Leetcode. So let's fastly code the approach which we have just discussed. And in order to code it, what do we need? We need two heaps. Okay, the very first one is the left heap. So let me just write it. We'll have a priority queue of integer type, and let me name it as left, and this left heap is nothing but a maximum heap. Okay, similarly I also need a minimum heap. So here I will write a priority queue of integer comma vector of int. Okay, and we will have greater of int, and we will name it as right. This is nothing but our min heap. Okay, I hope that you know how to declare minimum and maximum heap in C++. Okay, so now let's fastly code this particular function, which is add num. So firstly we will write the condition that if left dot size is equal to 0, or you can clearly simply write that if left is empty, right? If the left is empty, or the current element which we are getting from our input stream is lesser than the left dot top element, then we need to store this element into my left heap. Okay, so here I will write left dot push. I'll write left dot push num. Okay, and if this is not the case, then what do we need? We need to store our element into right heap. Okay, so here we will write right dot push num. Okay, I hope it is also clear to you. And after doing this, we need to balance the number of elements. Okay, so here we'll write our first condition that if if left dot size is greater than right dot size plus 1. Okay, if this is the case, then what we'll do, we will put element into our right heap. Okay, so here we'll write right dot push left dot top. Okay, and then we will do left dot pop. Okay, so here the spelling of left is wrong, we'll have left. Okay, and else if, here we'll write the second condition that if the right dot size is greater than or even equal to left dot size plus 1, right? If this is the case, then what we'll do, we will push element into our left heap. Okay, so here we will write left dot push right dot top, and then we will pop out elements from my right heap. Okay, so here I'll write right dot pop. Okay, and here in this way this particular function will get ended. Okay, so now we need to think of the find median function. Okay, so firstly we need to check that if the left dot size is equal to right dot size or not. Okay, if the size of my left heap is equal to the size of my right heap, it means that we have equal number of elements in both the heap. It means that we have even number of elements, right? If we have even number of elements, then we know that our median is nothing but left dot top plus right dot top whole divided by 2. Okay, so let me add some parenthesis here. Okay, and the return type is double, so I need to typecast it into double. Okay, so here I will write double as well. Okay, and if this is not the case, in the else block, if this is not the case, it means that the number of inputs are odd, right? If the number of inputs are odd, then what I can do, firstly let me just typecast it into double, and now I can just directly return left dot top. Okay, so this is our code for this particular problem. I hope it is clear to you. Let me run this. We have some compilation error. Okay, so I forgot semicolon. Now let me run this. Here also I missed semicolon, so let me add a semicolon here as well. So here you can clearly see that this particular approach is accepted, and let me submit this. So here you can clearly see that this particular approach is accepted. So I hope the code is clear to you, approach is clear to you, intuition is clear to you. You have understood that why we are using two different heaps, why we are using a maximum heap and a minimum heap. So I hope this video was helpful to you. If it was, then make sure that you like to this video. Don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel. And we will meet again tomorrow with a new question.